welcome to DevTool Times. So if you're new to the show, DevTool Time is a bi-monthly web series where we invite awesome developers such as Paul Jolly today, who will showcase their favorite dev tools, their workspace, workflows, and also share some productivity hacks with us. Let's kick it off with some introduction. My name is Vanessa Ortiz. I'm the community advocate at SourceGraph, and I'll pass it on to my co-host, Byung Liu.
Hey everyone, I'm Byung. I'm the CTO, co-founder at SourceGraph, and really excited to chat with Paul today. He's going to show off his workstation as well as Q.
Hi everyone. Thanks for having me on this show today. My name is Paul Jolly. I'm one of the core maintainers of the Q project. I also co-created Play with Go, which is a series of tooling-based guides to the Go programming language. I contribute to the Go project as well. Created govim, which is a plugin, a Go-based plugin for Go development, which we'll talk a bit about later on. And I help maintain a number of other open source projects as well.
Nice. And if you want to follow Q on Twitter, definitely follow him there, somewhere here on the screen. And yeah, how about we just start off with, how about the image of your workspace? Do you have that handy?
I do.
There you go. I love the dictionary.
Oh, you got a printer.
Yes, this the printer is just something I found myself having to buy last year, which was, I felt very sad about having to buy a printer.
How did you solve it before then? You didn't have one at home?
I just managed to avoid it, but for some reason with kids, and there are certain forms that need filling out on paper, and so the printer arrived.
Yep.
Nice.
I had to go through the same a few months ago.
Yeah,
also, no more printing at the office.
Yeah.
It's not a thing anymore.
Yeah. But otherwise, it's a fairly basic setup, to be honest with you. A standing desk is something that I've really gotten used to over the last 6 or so years. I find that just as a productivity hack, I find that helps massively because I just stay a lot more awake because I'm standing.
Yeah.
How long are you able to stand for at a time? Because I've found, I've used standing desks in the past, and I get a little tired after maybe like 20 minutes, and then I sit right back down.
I stand the whole time.
Wow.
Oh, wow.
Yeah.
You're standing now.
How many hours is that?
So if you see me sort of rocking around like this, it's I am literally standing. I haven't actually had a seat for years. There's another productivity hack. You save money on not having to buy a chair. But no, it's just something that I've gotten used to. And as I said, it keeps me much more energized and awake. So
Awesome.
I should try that out. I remember you mentioned that your MacBook isn't the newest.
It's definitely not, no. Yeah, no, it's a late 2013 MacBook Pro. I think it was, having spoken to some of the folks who work in Apple stores, they say it's one of the best MacBook Pros there was, just in terms of the combination of kit. Importantly, it's got the real-life function keys as well, which I use heavily within my developer workflow. No touch bar for me. But it is getting quite old now, and it sort of it does sound like it's taking off at times. So I'm very much looking forward to the announcement of the new MacBook Pro. And I saw in your tweet that you were disappointed not to see the new MacBook Pros announced yesterday, but somebody tells me that they will actually be announced next month.
Ooh.
So fingers crossed for that.
Insider. Right. Is there anything else you want to highlight?
Yeah, I don't think so, really. Other than about the actual hardware itself, it's very uninteresting. Just regular set of headphones there and mic that sort of has become pretty much the standard home office setup these days, right? So nothing else to mention there. Yeah,
how do you actually manage to? I mean, you're a developer. You are running really hardcore things on your laptop, I would assume, or do you use something to help you balance the load?
Yeah, so it's a good question. Actually, I do most of my development within Linux itself. And like one of your previous guests, I use VMware Fusion on top of macOS and then run Linux within VMware Fusion, which works incredibly well. Indeed, it's actually more performant as far as disk access is concerned than running, say, for example, the Go compiler natively on top of macOS itself. So bizarrely, running within a VMware on top of macOS is more performant.
Why is that?
I've no idea. There are actual numbers to prove it as well.
Wow.
Yeah. I certainly it's above my grade to understand those sorts of things. It was just something I noticed in sort of comparison when we were I can't remember what we were debugging an issue, a Go issue, and I was just doing a comparison with how it performed on macOS natively as opposed to within Linux, because I can easily flip between the two, obviously.
Yeah.
And it was way more performant. I think it was in the early days of modules, actually, because modules does a lot, obviously, in terms of accessing files on disk.
Yeah.
In the Go world, when it's, for example, parsing the module cache or whatever it might be, things were just significantly more performant. I couldn't believe it, and no,
that's crazy.
We did a bit more digging, and it was verified on other bits of hardware. This may well have resolved itself in sort of later versions of macOS, but on the version that I'm stuck on, it's definitely still an issue.
Nice. Well, do you want to just showcase everything from your desktop?
Yeah, sure.
Oh, there you go.
So yeah, this is pretty much it. Michael Stapleberg was one of your previous guests, and he wrote the i3 window manager.
Oh, you use i3? Yes.
No, I'm not using i3. No, I built it up and then I just took it away there. This is kind of like one of the predecessors to i3. I think it's called Awesome. But it looks very like i3, and I think the migration path to i3 is hopefully going to be fairly straightforward. So as you can see here, I just have a number of just within the window manager. Hopefully this is actually clear. It looks like it. They're not actually called workspaces in Awesome. I think they're just called windows or something like that. And you have the concept of just like multiple windows here, and you can see within that I have a fully tiled terminal. Very plain terminal as well, just Xterm for speed. And then within that, I've got a very dark base theme, just because I find that's much easier on the eyes. And Vim is my editor of choice here. Nothing really to say about that other than it is Vim as opposed to Neovim, which I think TJ would be a bit disappointed at.
He's in the audience.
He's in the comments right now.
But no,
wait, why Vim and not Neovim? If you're willing to disclose.
No, surely. It was actually, so back in the day, this is sort of like 2014-ish, I got interested in Neovim because it was really kicking off around that time. And also wrote a sort of proof of concept Go plugin manager for Neovim at the time as well, because I was writing a lot of Go, and I wanted to write Go plugins for Neovim. So I wrote a sort of proof of concept at the time, but then just didn't really stick with it. I can't remember for what reason, to be honest with you. This is all pre-Go Please, many years before Go Please sort of existed. So Vim Go was still the thing that was the main plugin for Go development in both Vim and Neovim. So there wasn't any distinguishing features. Then Vim itself, Bram Moulinar started to do a bit more development on Vim and really enhance things like the plugin support. And also sort of adding features that were very well oriented towards like language servers. So pop-ups found their way into Vim as well. And it was just at the same time that the stuff was really picking up speed on the Neovim side of things. And I just thought, I'm keen to write a plugin host in Vim or Neovim. The Vim stuff was coming along nicely. I'd just been using Vim for forever at that point. I thought, I'm just going to go with Vim. And so that was actually when I started writing govim, the Go-based plugin for Go development in Vim. And it just, I haven't actually moved from there because I have everything that I need within Vim. There's so many reasons I get it to move to Neovim, and there's people twisting my arm the whole time. I just haven't got around to considering it properly. It's one of those things that's on the list.
Yeah,
Got it.
I'm sure TJ will be interested in collaborating.
Yeah.
And why not Emacs, if you don't mind? I'm just kidding. We're not going to go down that road hole. Let's move on.
I think it's like 21 years of Vim. I've never even loaded Emacs. So.
Got it. If you're listening out there and you use Emacs, DM me. Would love to get you on the show.
Moral support required, right?
I do feel like the most of our guests have been on the Vim and Neovim side.
It's just a never-ending stream of Vim.
Can I just say better luck next time, Biang, right? So it's really nothing against Neovim. I think that the work they've done on that project is fantastic, because they sort of, with Neovim, they've also reduced the bust factor, if you like, associated with Vim, of sort of Bram being the main contributor. And I think that's an important thing from an open source project's perspective. And they've just added a ton of features as well. The inbuilt LSP support is, I think, a really critical one, because that sort of brings Vim on a par with things like VS Code. Just that out-of-the-box experience is, I think, the kind of thing that people are really looking for in an editor. So, yeah, other than that, I can just sort of have a quick demonstration here, if you like. Oops, hang on.
Yeah, your workflow.
Yeah, just so, for example, this is, now I'm in the Q project here. And the directory here. So this is a Go-based project, obviously. And what I tend to use within Vim quite a lot of the time is a plugin called FZF. Indeed, FZF also exists on the command line as well, if your viewers are familiar with that. So you have this fuzzy finding type completion. So here I'm just looking to complete a file name. So for example, it doesn't matter what it is. And so there, just with FZF, I've actually just been able to fuzzy find and complete a file name for, well, in this case, it's just the command ls. But FZF has this wonderful feature that same UI exists within Vim as well. So I use it considerably within Vim. So here is like the FZF UI within Vim. So here I'm just fuzzy finding to open a file, and now I've opened that file. But one of the really cool things that they've done with Go Please, they have symbol search working across your entire workspace. And your entire workspace is really defined as your main module and all its dependencies. So here I'm within the Q project, and so the main module is the Q project itself. So now I can jump into symbol search within this and then just fuzzy type a value here. I'm sort of being a bit more precise, and do things like also providing regular expression type values here. And now I can jump to this symbol here. Now this starts to get super powerful. So now I'm not a mouse person at all. These are all keyboard shortcuts, and indeed I can just sort of show you how I'm triggering that. So I use /s in order to actually trigger the symbol-based search. Then obviously typing something like that takes me to it. And then within there, I'm just using a lot of keyboard shortcuts for, say, jumping to definition, jumping out of definition, finding references. And then down at the bottom here, let me just turn off the keyboard shortcuts for a second. The quick fix window within Vim I use a lot, and I actually use it in a sort of overloaded capacity here with my Go development and sort of edit development. So here it's being used for the actual references that I just searched for, the references to the runtime type. And then I've got another plugin that I use quite heavily that is called, it's by a sort of fairly prolific Vim plugin author called Tim Pope, and it's called Unimpaired. And it's just got some really sensible defaults for actually all the common types of Vim action. So for example, here we're looking at the references to the runtime type. Let me just turn on the keyboard shortcuts again. And what you can then do is you can iterate through those references just using, here I'm just using, you can see the square bracket Q to the next one, or open square bracket Q to go to the previous one. Or to jump to the first one. So this has now just become muscle memory for me. And it was only through sort of like a demonstration from somebody that said, hey, consider this plugin here. But I find it, when you actually build it into your workflow and then you reuse this quick fix window quite a lot of the time, because errors also appear within here. For example, I'm just going to create some errors within the project here. Now you can see I've created a whole load of errors off the back of breaking the name of this field here. That same quick fix window is being used for all the errors associated with the change that I've just made. So this is super powerful to my mind, to be able to have these basic concepts within here, and just the same sort of keyboard shortcuts, whether you're searching for references or iterating through breakages that you might have in your build as well. So yeah, otherwise it's a fairly plain setup. The only real demands that I have of my setup here are that it's nice and fast, which is why it's a sort of a fairly plain and simple Xterm setup here. I just need it to be nice and snappy.
Yeah, that's cool. Do you use autocomplete at all? Is that?
Yeah, I do. Yeah.
Okay.
So I don't know. Let's just take this example here. All of this actually comes from Go please, obviously, because here I'm using govim within Vim, and govim is talking to a go please backend. Indeed, one of the nice things about go please is that they have this concept of a remote go please instance as well. And so even though this is all by remote, it's all local to my machine here. But between, let's say, for example, I'm then on another window here. This is actually Q, but let's just say we were to jump to another, and just open another, I don't know, whatever Go file here. This is now using the same Go please instance on the back end. And so from an efficiency perspective, there's a lot more shared caching going on. And so things like code completion, caching of all the symbol types, except all the symbols when it comes to symbol search, that all is now shared but in that single remote instance of Go please. And so the Go please authors have done a fantastic job there of making the development experience with Go super snappy by those sorts of features. So yeah, code completion is very fast as a result.
Awesome.
I also got very basic things like mouse over. I don't use the mouse, but if I have just put the cursor over that type there, but I can trigger the same things using the keyboard as well if I want to pull up the documentation for something just quickly. The resolution on my screen here is much higher than it would be for ordinary dev work, which is why things are sort of slightly rolling off to the right a bit.
Got it. We got a lot of love for T-Pope in the chat.
Oh, really?
Yeah.
Yeah, just prolific. I mean, I can count maybe 5, 6, 7 plugins that I use from Tim Pope. Fugitive is another one, which is all about sort of Git integration. So here you can see I've just done a git blame on the file itself. The Emacs users will complain that this is nowhere near as good as the Emacs plugins. Yeah, I get that, but
the Magit plugin.
Yeah,
for Emacs.
Other fun things like just simple stuff, for example. So if I just highlight these two parts of this file here, this is like a visual selection in Vim. Yeah. Another one is what's called commentary, which allows you to comment and uncomment blocks of a file, whether they just be some sort of motion that says, I want to comment out this section here. It's just such a simple thing, but a plugin like that becomes super powerful where you can comment and uncomment things in a language sort of in a way that respects the language that you're currently working with. So it's just small things like that, which when combined really make sort of your development experience that much more pleasant.
Cool. What does your Vimrc look like with all these plugins?
It's not actually that exciting, to be honest with you.
Okay.
It's really I don't have it shared on the basis that I don't trust myself not to put sensitive stuff in my config files and or sort of keep track of making sure I haven't put sensitive stuff in my config files. But generally speaking, it is just this very plain list of plugins being loaded there with then optional configuration on top of those. So it's the loading of the plugins, then the configuration on top. govim we've got sensible-ish defaults with govim, but again, for things like the symbol search stuff, that all just needs a bit of tweaking for the custom setup that I have here.
Got it.
Yeah, I'm just trying to think if there's anything else sort of go wise that is worth talking about govim. We sort of talked a bit about govim.
What about Plan 9 for Vim space?
Yeah, that's an interesting one. So that really, let me just think, what's the main reason that I use that now? Because it's actually sort of been superseded by a couple of other plugins that I use. Actually, the main one is as follows. Trying to think of a good example here. So if you imagine, let me just break something here. I'm just going to do something really bad in here, okay, and then if we then just do a go build command go, for example, oops, where are we? Sorry, command Q, wrong. What am I doing here? Go command Q. this should actually fail. Fine. So one of the things that Plan 9 for Vim space, and this is really comes from the Plan 9 operating system itself, is this output that you see from the Go compiler here. We have the name of the file, colon the line number, colon the column offset here. What's nice is to be able to actually, within Vim, for example, well, let me just do it over here, just copy and paste that. And I find myself doing this a lot, despite having good integration within the editor. And this then works, except I'm in the wrong directory. Let's just fix that. Command Q. That then works to take you to the offset.
Whoa.
Yeah. So that's why having good consistency in terms of tooling output, to my mind, is really important, is that you can then compose things in a really nice way in terms of workflows. Yeah. So having standard output in terms of compilers, and this is why I had a bit of a gripe with the way that TypeScript decided to output, this is going back a number of years, but output their compiler errors in a different format. It made that people then sort of had to adjust their tooling in order to work with the output from the TypeScript compiler, whereas okay, if there was sort of some standard that could be agreed on, then all editors would be able to use that sort of output. And I realize that sort of LSP has sort of taken away the real need for this kind of thing. But generally speaking, that sort of composition of tooling is a really nice thing. So that's the main reason that I use Plan 9 for Vim space. I think there were other things, but I can't remember off the top of my head now. That was the main one.
Got it. So you weren't using any of the like Acme emulation features like mouse.
No, there was no. So there's a whole load of stuff that exists within that project as well to do with mouse chords and things like that. And I've never been a big mouse user. So Russ Cox gave a really good demo of how he uses Acme, and it uses the mouse heavily. And I've never got into that. So as a Vim user,
cool.
Not unusual. I feel like all the Vim users are very keyboard heavy.
Yeah, totally. Yeah.
Should we look into Q now?
Yeah, surely. So Q, what is Q? Hang on, let me just get the. Hang on, I've got to. So this is the homepage for Q. That's maybe if my screen is still shared, that's probably a good thing to have up on screen. So what is Q in the first instance? It's an open source language. We've also got a rich set of APIs and tools for defining, generating, and validating all kinds of data, whether that be configuration, APIs, database schemas, code, you name it. It was a project that was started back in, I think, around 2018 by Marcel van Lohazen, who at the time was at Google. And Marcel has got sort of a deep background in configuration management. He was I think he was on the early team of Borg. Biang, you'll be able to sort of reference all these examples here from the Google side of things. So he has, I think it's around sort of, he recently left Google actually to work on Q full time. And so that's an exciting stage for the project next, is that, you know, what's going to come for Q with Marcel able to dedicate his full time to it. It's sort of solves a number of interesting pain points. So if you've ever found yourself sort of fighting with white space in YAML, that is one that Q looks to massively solve. If you found yourself fighting with templating, of configuration templating, sort of thinking Helm charts type territory here, that's another area that Q looks to try and address. Sort of trying to solve this problem of how do you manage configurations at scale, because of all the sort of, you can think of whether it be CI or things like Kubernetes, where you have got very large configurations for systems themselves that have lots of configuration required. Managing this lots of times across teams, and perhaps if you throw in a bit of policy is there as well. Doing all of that at the same time becomes quite a task. And so Q really is effectively the product of all Marcel's experience with Borg, his time at Google, configuration management, all the issues associated with it, the issues that he identified as sort of being main contributing factors towards things like outages at Google. And so it tries to solve as many problems as possible, even around the maintenance of configuration as well. And do it in such a way that actually it's really nice to work with from a user perspective. It's got a lot of background as a language as well from Marcel's time when he was working in natural language processing, where you often have non-engineers, maintaining configuration. And so it's meant to be very approachable for non-engineers to maintain configuration as well. Lots of teams maintaining different parts of a configuration, but also then having this really nice unified view of your configuration across many different systems, as opposed to different configurations and different tooling for different parts of whatever your system may be.
And just real quick for folks who don't know, like Borg inside Google is basically Google's internal cluster management system, which is kind of a spiritual predecessor to Kubernetes, right?
Yeah, precisely. Sorry, I forgot to mention that. Yeah.
And at least when I was at Google, very briefly, like 10 years ago, there's a internal meme about so Borg was the cluster management system, and Borg-Mon was the configuration language for configuring Borg clusters. And there's a meme about like how you needed Borg-Mon readability to make any substantial changes to clusters, and that was like a huge bottleneck. And from what I understand, a lot of the developers didn't consider that a super user-friendly or forgiving language, and I'm sure some of that motivated Q.
Yeah, I'm sure Marcel's will speak to this sort of far more eloquently, because it's sort of I think he was there for just around 18, 19 years, and there's sort of a lot of experience in terms of Marcel was also on the Go team. And I think there's a lot of influence from the Go project in terms of how the project is run, structured, but also the approach to tooling, being very supportive of things like code generation as well. It's trying to solve a lot of things, and I think that's part of the challenge with Q as well, is to describe Q in to folks is challenging, because it can solve lots of different things at the same time, and it's just about working out how best to describe a use case for somebody that is tricky.
Yeah. So someone in the chat said, sounds really cool, but needs a good problem to try it on. So do you want to dive into an example?
Yeah, sure. So let's we can just look at a bit of Q itself to start with. Is my screen shared okay? Can you see this?
Yes.
Okay. So Q really sort of supports the concept of not only declarative data itself, but also schemas. So for the purposes of validation here. So this is just a very simple example here, just to give a bit of a flavor for Q itself. So let me just make sure I've got some notes here on screen as I'm working through this, so I can reference the key parts. So Q itself is a superset of JSON. And so there'll be lots of familiarity as far as the look and feel of things are concerned. So here we clearly have a struct type here. We don't actually have any list types here, but lists are also supported as well. So down at the bottom here, we have Moscow, which we're declaring. You can see there's no outer curly braces as far as Q is concerned here. And we're also omitting the quotes on the field names themselves. They are sometimes required where you have what would be otherwise illegal characters, but you can omit them. Commas are optional, so it would be perfectly fine for me to put a comma here, but they are entirely optional. You can have trailing commas at the end of lists, for example, or struct definitions if you want them as well. So there's a lot of usability features. You can see comments in here as well. There's a lot of usability features that already make this more appetizing than JSON, for example. And it's sort of, if you can sort of imagine like a best of breed of configuration languages and sort of schema specification languages, Q sort of sits nicely in the middle of all of that. And indeed, let's just have a quick look at how this evaluates here. So here I'm just going to QEval, and QEval is, I'm using the Q command here, as you can see. And QEval is a way just to saying, hey, just tell me a bit about this, in this case, this file here that you have. And you can see that Moscow effectively, Moscow at the bottom here is actually a specification of some data, whereas the other two, and they're sort of, that's indicated by the hash here, which identifies them as definition, said this is actually a schema. So Moscow here, we're saying that Moscow is effectively an instance of a large capital. And what we're doing here is using a conjunction to say it's a large capital, and I'm going to give you some more information about this, i.e. further constraints. Because let's look at the definition of large capital, and large capital is an instance of a municipality with some further constraints. So let's go all the way back to the beginning, a municipality. Here, this looks very much like a type definition. And this is another great thing about Q. You can have data and your schemas sitting alongside each other. Schemas themselves in the form of definitions don't get exported. So if we were to do a Q export here of this file, we only see the data. And we can just be a bit more tricky than that as well. And we can say we actually want this in YAML format as well. And the nice thing about Q is it's kind of like an interlink where it's able to translate through between lots of different encodings, whether they be data encodings or even schema encodings as well. So we haven't got an example here, but we can look at one later on, where effectively we translate between a JSON schema representation and a Q schema. So here, this is super simple.
Can I pause you there just to
sure.
kind of restate some of the things I understand it properly? So Q is a language for describing both schema and data.
Yeah, exactly, yeah.
And then Q eval, what that does, basically strips out all the comments, but preserves both the schema and data parts of that. And then the export is you're just exporting the data part because you're exporting something like JSON or YAML that doesn't have a notion of schema built in.
Totally, yeah. And so there are lots of different, we can sort of, QDef is another way that we can look at this specification here, these declarations, excuse me. And QDef retains in this situation the comments. And so these are just different views on the declarations that we have here.
Okay.
But in this situation here, all we're looking to say is, well, here we've got a type definition at the top for municipality. And we're sort of saying that a large capital is a bit more specific than that. It is a municipality that has a population of greater than 5 million. So here, this constraint is doing something more than just giving a type. It's actually giving us a range as well. So then when we come to specify Moscow, which is an instance of a large capital, we're saying that it's a large capital. So guess what? It's going to have a name, a population, and we're also going to indicate that it's a capital as well. But here we can just vet that this is valid. In this case, there's no problems here, because if we had a population that was not greater than 5 million, we would have an issue here. And so this is another nice thing. We have in Q types of values, but you also have the ability to specify sort of ranges of valid values as well. So it gets to be much more powerful than just saying, hey, this is a string, or hey, this is an integer field. And this is where, if we, for example, were importing some specification from, say, Go code of constraints, we can represent some of those constraints within Q as well, and then translate them to a different format. So, for example, export that as Open API. And so Q ends up sitting in the middle of a lot of these, in a lot of these instances, to be able to translate between these different formats and have like a single source of truth that works nicely, and all your tooling can then hang off that. So you can either generate your Q from Go, or in the future generate Go from Q. Or protocol buffers, Open API on the schema side of things. And as we've seen sort of from a data side of things as well, you can also just translate between what is Q representation, YAML, JSON, and others if we wanted to support those down the line.
Cool. So it's kind of like a generic data representation language. And like, so what doesn't it do? It's not like a full programming language, right?
No, it's not. So it's not a full programming language. It's not Turing complete in that respect. And it's much more geared around how Marcel will speak to this, far more eloquently, but about limiting you to do certain things within the configuration language that mean that it's harder to sort of cut yourself, if you like, when you're maintaining large configurations. So you are limited in what you can do, but there are a number of things. So let's just jump to sort of a quick example, another quick example here. Validation is, so let's look at a concrete use case, for example. Here we've got another definition of what is a language here, and the language has a tag field, which is of type string, and a name that must start with an uppercase letter, for example. So this is fairly simple, and then we define an actual field here, languages, that is of type, arbitrary length of number of languages. Then we've got a YAML file down the bottom here, which has a field languages, which has got a number of items in that list that should obey this, the schema that is language here. So if we just do a qvet of schema.q here, and data.yaml as well, you can see now we are validating the YAML in this instance to ensure that it matches the schema, and it doesn't, because we have an incorrect name here that does not start with an uppercase letter. fix that. So this is a fairly trivial example of using Q from a validation perspective, but validation itself ends up being an incredibly powerful thing when you're looking to try and move as early as possible into your configuration pipeline, checking that your configuration is valid. And so having schemas that you can, alongside the data, verify that your configuration is valid ends up being incredibly powerful. And instead, for example, of leaving it to the last minute where you're trying to deploy something and it's too late at that point, or you're trying to quickly work out why your configuration is invalid, if you have schemas that can help identify problems early, that just makes collaboration and management of configuration a whole lot easier.
Nice. That also answers the question of one of our audience members. So this is great.
Sure. Yeah, it is. It's the so I think I briefly saw the question there. How is extensible is the validation logic? It's pretty extensible. There are limitations on what sort of computation that can be done within Q. So in that respect, Q, the language itself, is hermetic. So it's designed that it should be side effect free. And that, from a complexity perspective, is a decision that sort of comes from years of experience of having been burned by things that. So, for example, you could use a language like Go to specify your configuration, but Go can have many side effects, and you're not constrained from doing that if you were to specify your configuration in Go. And so that is where it's slightly problematic to use a language, a full-blown programming language like Go, and Q is much more constrained. So it's very principled in the way that it tries to help you structure your configurations.
Can you do things like templating in Q, or is that like outside of the domain?
Yeah, absolutely. I wonder whether actually now would be a good time to sort of jump into the example. I don't know how we're doing time-wise. So yeah, Biang, you have the deploy source graph repository.
Yes.
Is an example that we've sort of exchanged messages on.
Yeah.
Let me just jump to that now.
That is so for those listening, that's the Kubernetes manifest that you can use to deploy source graph into a Kubernetes cluster.
Yeah, so let's just have a look. I've already forked deploy source graph here. So what I'm going to do, I hope the demo gods look kindly on this demo here. So I'm just going to jump into that. And what I'm going to do as well is just check out the branch that you have for your configurator instance here. And so we're just sort of working from the same instance. My understanding, if Biang, of my understanding of any of this is wrong, please just shout. But effectively what we have here within the base directory is effectively the YAML specification of all the Kubernetes objects.
Yes.
Yep. So what Q is very good at is helping to remove boilerplate by lifting to the top, to sort of a much higher level, things that are common between those different configurations. So here we've got the different services that form part of the source graph configuration here, and there's a lot of regularity between these different objects, the different services. Yeah, and maintaining that, I'm imagining, is actually quite a headache. And so what Q is very good at is here. So what we can try and do is actually just, first of all, sort of give a bit of a demo of how Q can be used to import. And what we're going to do first of all is actually just import from the existing YAML files that exist there. So we have a Q basis for our analysis here. So let's just have a quick look at all the files that we've created here. And let's just have a look at PGS. Oops, excuse me. So let's have a look at the Postgres service YAML, for example, and alongside that, the Q equivalent. So what's nice with Q is that you can, instead of looking things on an individual file basis, actually look at things as like a unified configuration. And that's what we're trying to do here. So we're putting everything within a single package. And for anyone who's familiar with Go, packages have a very similar concept in the Q world. But instead of having all these objects just exist at the top level, we're actually choosing to sort of namespace them according to their kind and the name here. So if you just saw the command that I ran a second ago here, that was exactly what I was doing. I was saying I want to import a whole load of YAML files here. And I want to namespace them according to the kind. So this first part here. And then with it sort of as a subpath of that, the actual name of the object itself. which is why here we find service, and beneath that PGSQL. And in all the other YAML files that we have, they're similarly namespaced. So this is where we start to see quite a lot of the, and Biang, you can sort of catch me out here when I get these wrong here. But this is, let's just do a quick test first of all to make sure that this evaluates properly. Oh, excuse me. So within the base directory again here. So fine, this all evaluates successfully. We don't sort of particularly care about the output at this point, but this is now just verifying that the Q import that we did from the YAML files evaluates successfully. So let's just try and do a bit more in terms of optimizing things here to do exactly what you said, Biang, of a bit of templating. First thing I'm going to do, though, is actually lean a bit on the validation side of Q. Because what we can do in the Kubernetes world, they have the Go code as their source of truth. And so what you can do with Q is actually import from Go code type definitions so that you have schemas in Q to work with. And so we're going to do that right now. So let's just jump up to the root of the repository. And this is a Go module already, this repository. So what I'm going to do first of all is create a Q module. And Q modules exist in exactly the same way as Go modules do, as being like the unit of versioning, but also the main module is the way in which you can specify what your dependencies are. And we haven't completed the dependency management side of things on Q yet, but for now it sort of exists so that you can vendor things. So what we're going to do now is I'm going to rely on my previous commands here. We're going to get the first of all, we're going to get the actual the package where the Kubernetes types are defined. And what we're going to further do, go, and we're going to define a file here which allows us to declare a dependency on that, qdeps. So this is just a way of us declaring a dependency. Excuse me.
So you're fetching the Go package where in Go they define types for Kubernetes objects.
Exactly, yeah.
But that's going to be a little bit lossy, right? Because the Go type system can't capture, all the nuances, I think.
Exactly, yeah. And so that's also, so for now, there is a fairly good approximation of what the types are. Okay. But they do, within the Kubernetes world, they use, my understanding is they use Go as the source of truth. So as far as the Q validation is concerned, it's definitely good enough. So there are things that aren't perfect in terms of the translation, but it's for the purposes of this example, at least for now, it's good enough. It can be enhanced, and there's ways in which you can augment the definitions.
Can you do the same thing? Don't do it here, but like could you do the same thing with like TypeScript types?
Yeah, indeed. So that's a very good question. So the ability for Q to, we'll just see that, and give me 1 second here. I think what we'll be able to do, so now that we've declared a dependency on that Go package, what we can do is do a Q get Go. What this is going to do, it's going to get that Go code, analyze it, and then generate Q definitions from it. So in much the same way, Biang, is just as you were asking, could we do this for different languages? Absolutely. It's just a case of writing the equivalent of the equivalent Go analysis. This is taking longer than it should, which tells me that this, oh no, there we go, that's fine. Yeah. So now we find if we were to look in our q.mod, we're going to find a whole load of Q that has been generated from the Go there. And this is, as I said, like a vendor. So now what we actually want to do is we want to start specifying, and I'm going to cheat slightly here by doing a bit of copy and paste. So we're going to go back into our base directory. And this is at the top level of the Kubernetes directory that you have. So what I'm going to do here is just paste this in and then explain it. So here we're referencing, notice there's something else that is supported by Q here. That's the ability to import packages in much the same way that you can with Go. So we're importing the core types and the apps types as well. And if you recall, let's just make this a tiny bit bigger. The way in which we structured our the import from YAML is to say that actually we want to put things, namespace them slightly better. So services will exist below the service field, and that's going to be a struct type which has got fields that are the name of the service, and below that the actual specification of the service itself. So here on the left-hand side, we're saying service is going to be sort of any number of string fields, and they will be of type v1.service. But now what we can do is we can just do a queue eval to verify that. Where are we here? We're in base, good. So now we've further constrained to say, fine, things that are defined under service and deployments, just doing 2 for now, should match those 2 types. And let's just verify that we actually have some consistent. Oh, we've got a bit of an issue there. Okay, so let's just jump into that and see what the issue here is. It's saying there's a mismatched type. So that basically means what we imported from YAML does not correspond to the type that as is defined on within the Kubernetes Go types that we then imported as well. And it's saying this field, it's mismatched type null and list. We're sort of running about it. Okay, that's fine. That is actually correct. There's an error there. I think there's a couple more of these. Let's just, here we're using, I'm just going to quickly jump in and fix all these. Here the validation is helping us to verify that essentially the queue that we imported, the YAML that we imported is valid. So this is the validation side of queue. It's helping us here. And then we can do one better though. We can start to reduce a bit of the boilerplate. So let's just get ourselves to a situation where we have some valid queue according to the types. Fine. So we now have some valid queue. Let's jump back to our top level here. We can do a bit better as far as reducing the boilerplate is concerned. And this sort of shows where there is the power of the tooling that's associated with queue as well. Mm-hmm. So let's just take a quick look at PGSQL. And let's just have a look here. So there's quite a lot of, well, we know metadata.name is, there should be a correspondence here between the name field and the name PGSQL at the top here. So let's just fix that. Let's remove that boilerplate there. So what we're going to say is metadata, and what we want to say is the name field, and we want to say it's kind of the same as whatever value appears in here. So let's just do that. We're going to define an alias in here, and then reference that there. That's great. So we could just do a queue eval if we wanted to over on the right-hand side, just to make sure that it evaluates all correctly, which it should do. That will effectively ensure that we have consistency, unsurprisingly, because that's how we imported things in the first place. Mm-hmm. But now what we can do is actually run a tool called qtrim. Now that we've specified this at the top level, we're effectively saying this is a constraint on the definition of service itself. And trim will allow us to remove from the actual instances themselves those fields that can be inferred from elsewhere. So if we run qtrim across all of our configurations here, what we will find is this field here disappears. We just wait for qtrim to run. It's a fairly significant size.
So it's like collapsing the schema. Like it's finding redundancies in the schema and saying like, well, you don't need that because...
Correct. Yeah.
Like if you did that on your first example, I noticed there's like a duplication of like capital.
Yes.
Like so like the name string. Like if you ran Q, like it would get rid of that name field in large capital.
Oh, hang on. I haven't. Let me just fix this again. There we go.
Keeping you honest.
There you go. So you can see it dropped we had capital there because it can be inferred from the fact that
that's pretty cool.
So this is the power, though, of the tooling aspect of Q and the fact that we're looking at it from a unified perspective. So you can sort of imagine, let's just do one or two more very quickly here. So API version is one, and Biang, please shout out if there are others. This is where, for now, there's sort of a good deal of sort of eyeballing required. This is an obvious one because it is a service in this situation. And this can, of course, be repeated for the other kinds of objects that exist as well. So let's just run qtrim across this again here, and we'll just see when I reload the file on the left-hand side here, we'll see these two fields disappear, right? So you can see that this is helping to reduce all the boilerplate up to the top level, but it's also ensuring that we have consistency across everything as well.
So is this
they've done as well?
Is this leading to like once you've kind of factored these commonalities out, now like can you reverse it? And so like set a name or like. I guess I'm thinking about like the generation or like the templating use case where, suppose, there's a source graph customer out there and they're like, base manifest is good and all, but, we have a requirement where we need to add a certain security policy to every one of these objects.
Yep. So that's entirely possible as well. So I think one of the use cases, if I understood it correctly, is that where you have people who are customizing the default deploy source graph configuration.
Yeah.
What becomes tricky is rebasing against changes that you make upstream.
Yes. Right now we have not the best experience because when customers have customizations they want to make, they fork this repository, they make their changes, which is okay the first time you do it, but once once we ship an update, you have to rebase against that, and if there are merge conflicts, those are things you have to resolve, and that's painful.
Yeah. So one of the beauties of Q, in my opinion, in this respect, is that Q is all about composition. So if I, as a customer, let's just imagine I'm a customer for now. If I have customizations, lots of customers in there, customer and customization, that I want to make to the default configuration, I can specify that in entirely separate files, whether it be sort of at the top level, but they don't interfere in any way. I'm not mutating anything that you have defined as like your base configuration from source graph that is shipped. Yeah. The points at which things get vary. So my understanding of the TypeScript approach is you effectively take the base configuration and you describe it in terms of mutations. Now Q does not operate with in terms of mutations. It's about the compositions. There's no concept of inheritance either. Other than the ability to specify what is a default value.
When he says TypeScript, he's referring to like this hacky script I wrote that was just like, hey, I want to have a programmatic way of customizing this YAML, and so all that script does, it's written in TypeScript. All it does is it takes in the base manifest and apply a series of transformations.
Yeah. So I've got a sort of a little toy example here where again we've got a sort of a person schema, and a person has a name, of course, and then they have an age. And here what I've done is I've just specified that age has a default value of 42. So if I was to just do a Q eval on this over on the right-hand side, let's just do a Q export because that's slightly more exciting. You can see that the Gopher we then have exported has an age of 42 because that's the default value of the field age in this situation. But it's entirely possible for me to specify an actual value in the situation here. So you can see how from the base configuration of the source graph deploy perspective, if you specify things in terms of default values, then that's effectively the point at which any customizations can be specified by an end user of the deployment. And this can exist. There are lots of different ways and sort of fairly sort of exciting and complicated ways in which that can be done. But the interface, as far as the end user is concerned, is very straightforward. Very easily understood. And what's nice is that if you do end up rebasing against upstream, in order to, you don't have any merge conflicts because you're maintaining all of your customizations separately, albeit in separate files, that they're never going to conflict because they're entirely under your control.
Wait, actually, can you go over that part again? Like, what do you mean the customizations are going to be in separate files? Because my mental model is still like you define the schema and then everything kind of gets generated from that.
Yeah, so I did explain that very badly. All of the base files that you have here, I think we would look to potentially structure things slightly differently in a Q world here, but let's just sort of skip over that for now. Let's take this example here, and just because it's a nice simple toy example, and let's just shift the definition of Gopher itself into a separate file here. Let's just imagine that this schema effectively represents what you as source graph are distributing, and here this is my customization on it. That's not strictly the case actually, but so let's just make it slightly more interesting and say that here that we have a Gopher Q eval x dot y dot q. Let's just put all these in a package to make this a representative example, and so that we have the references, and then we can drop the. Fine. So here, let's just assume this is what you ship as source graph at the top here.
Yep.
What I can do is I can further enhance that, so I don't even need this here in this situation. So this is me maintaining separately from your base configuration
I
what
see.
effectively my customizations are.
And then you can compose them, and it will kind of like
Precisely.
overwrite.
Yep.
Okay,
exactly.
cool.
So when you're rebasing, this is a very sort of toy example here, but that separation is a key, and the composition result then being something that can be checked and validated up front, as you've seen with all of the stuff that we've done with Q here. It's all been about validation and catching things early. I would just rebase, run QEval. Do I have any errors? And then I'd be able to see where there are any conflicting values.
Can you do? Sorry, go ahead.
No, please go ahead.
Can you do something like, I want to apply a namespace to every, service object?
Yes.
Like, is there like a loop or for each type thing?
There are indeed. I'm just wondering where. I'm actually going to point folks at this point to a, because what we've done here is I'm going to make this a tiny bit bigger. This is the Q website. I've just jumped to the documentation part here. What we've done is we've barely scratched the surface here of a tutorial that goes through this in significantly more detail. That is the Kubernetes tutorial. And what you're talking about there is comprehensions, where you can specify, and let's just wait for this page to load here. And just down the bottom, there is a good example of a comprehension here, for example. Let's just make this a bit bigger. This is where you're able to, in what is sort of effectively like a for loop, specify constraints in a declarative way. So here we're just iterating over the specific object types here. And then within that, we are declaring, within that, we're saying, fine, for each of those things there, we're going to say there's a service. Within the service, we will then declare what is K here. Here's the name again. So there's a service that corresponds to the deployment daemon set and stateful set. So you can do these things in a very aspect-oriented way with these sorts of comprehensions. And again, all of this is designed to try and remove boilerplate. And so comprehensions, as you're alluding to there, can reduce boilerplate massively, because you can just iterate over a list of things in order to specify what is very common boilerplate, in this case, between all of these three object types here.
Got it. And so like, let's say you have like a set of schemas defined in Q that impose certain constraints, but the constraints don't actually imply a specific value. When you go and like generate, export to YAML or something like that, what gets omitted?
Very good question. So I think a good example there is the storage class example, as far as your deployment is concerned, because as I understand it, that's effectively like a required. Let me just jump to that. Deploy. Okay, customize default. And here, this is where you're specifying the platform. And I think that ends up selecting a storage class. Now, if you have something that is just defined as, maybe we can jump to a, let's just make this, this age field here an int. And let's just work with x.q here. So to take your example explicitly, it will say you've got an incomplete value in this situation because I haven't specified int. It's basically saying I can't export
Got
this.
Got it.
Because it only has a type associated with that. So that effectively comes down to something being like required field in some way, shape, or form as far as exporting is concerned.
Got it.
So in your storage class example, that would be a very good one where you say, hey, this is effectively required, and you would just be unable to export to a YAML full stop at that point until you have said, oh, it's an AWS or a GCP storage.
So let's say I have a Q file and I've supplied a name, and then I want to have a customization that supplies a different name. When I QEval that, will it like overwrite the old value, or will it throw an error saying like those two constraints are inconsistent?
Yeah, very good. So that's another good example here. So Q is all about constraints, and they can be as general as a type or as specific as a concrete value. So let's open Y again here. And let's just change this slightly to in the second file here.
I see. So it's like a definite value or something else. And when you emit something, it will choose the default. I'm guessing when it like emits something, it'll prefer the most specific value
It does.
Or, okay.
It does, yeah.
Got
But
it,
they
got
must
it.
not be conflicting, which is exactly what's happening here.
Okay.
So this is precisely where if you've got multiple teams contributing configuration, or for example, you've got the upstream source graph configuration for the Kubernetes deployment,
Yeah.
and somebody is customizing it in some way, the conflicting values is a no-go as far as Q is concerned.
Cool.
There's no concept of overriding in any way, shape, or form.
But you could just say gopher or string, and then it would be fine, right? Like if I.
Well, here in this situation, for example, I've specified gopher twice, right? Sort of, if this is like the upstream,
Yeah.
I've then sort of said in my local customization for this, I've said no, gopher's name is actually Paul, and that just conflicts.
What if I wanted to set like the default name as gopher, but allow the customization to overwrite that?
Just as the same as we did for age here.
Star.
Yeah, so we would just be able to
Oh,
say.
okay, got it. So that star operator designates that as the
So within a
default
disjunction,
value. Okay,
exactly. Within a disjunction, which is kind of like a sum type, you have this ability to specify what default values are.
I see. Okay. Cool.
And so that's one way in which you could. There are other ways. That's one way that you could, if you like, provide the entry points for customization within the default source graph configuration. There are others. And it's entirely up to end users ultimately as well, how they compose their source graph deployment.
Okay, this is pretty slick.
Someone's asking if you can also append to lists or maps using the AND operator.
Oh, that's a very good question. That might be a hint actually at a specific type of list. Which is called an associative list, and we don't have support for that yet because associative lists are quite common in the Kubernetes world. Sorry, I don't know which screen I'm on here. It's actually irrelevant to what I'm talking about, so I'll go to a blank one. Let's just do a... so appending to a struct is relatively straightforward. It doesn't sort of exist in the concept of appending to it. You just keep specifying fields. So for example, here we did go for age 99 in the situation. That would be absolutely fine. If because I've tried to specify an incorrect name here. That's absolutely fine. So you notice that this forms effectively part of the same gopher value here. It's just I happen to have split, and this is where the sort of the code generation sort of inclination of Q is good, because it doesn't. You can have this in separate files; they're part of the same package. You can split out the definition. So code generating this is very nice because, of course, it doesn't then have to all be within the same struct value here. You can. You're effectively just further constraining the gopher value. It doesn't matter where you specify those constraints. Lists are somewhat more tricky because lists are by definition closed. You can't append in the same way. So I can't, for example, it's sort of difficult because you can't even write this in Q. You can't split a list's declaration across multiple fields in the same way here, unless you have associative lists, which are much more like a map. And in that case, you can. We just don't have support for that yet. So for now, and there's sort of another thing that might enhance our ability to specify lists in a sort of a more natural way, and that's the query specification. That also doesn't exist yet, but it's one of the big features that people have asked about, and I guess that's where the question is coming from. How can we effectively break out our specification of list values? It's all oriented around that same kind of problem there.
Cool. So one final question.
Sure.
That's appeared. What would be the compelling reason to use Q versus a different functional config language like DAL?
Very good question. That's got a fairly long answer to it, and I would direct folks to some good discussions that exist in the Q repository for that. I think Marcel is also very much better placed to answer that as far as the specific configuration languages are concerned. But from my personal experience, the tooling aspect of Q has been an important one. So we've only actually looked here at Q as a configuration language. There's a tooling layer that exists on top of that, where you can very easily build tools that are reusable between different contexts. And that is a hugly powerful concept that exists within the Q project, as well as the API. It's a Go API at the moment. But we're looking to also have APIs for SDKs effectively for other languages as well. So that ability to not only have a configuration language, but extend it with tooling in a reusable way, to have a package ecosystem. We don't have that yet within Q, but that's very, very high priority. So much the same way that you can reuse Go packages, you should be able to do exactly the same with Q. So imagine everything you can do in terms of Go, defining a package, publishing it somewhere, and then having other people import that, reuse it, and compose configurations from that. The quintessential example we have is actually all of the Q projects, GitHub Actions workflows are specified in terms of Q itself. They reuse a common definition of what the GitHub Action types are, and that's just imported, and we reuse that across all of our the project's GitHub Actions workflows. So that kind of reuse, a package ecosystem, is a very compelling thing on top of the tooling and API, to my mind. But very happy to explore that. Marcel will also be much better placed to respond to that point as well.
Well, thank you so much for showing this off.
No problem
I
at
found
all.
this really compelling, and your dev environment is really cool, despite the Vim.
Yeah, well, a new machine required, definitely, I think, as well.
Coming soon, apparently.
Hopefully, yeah.
Very nice. Well, thank you, Paul. This has been very,
No
very
problem.
educational. I think
Sorry, there was quite a lot that we didn't get to as well.
People. Oh, no problem. I think you've already enriched a lot of minds with all this already. And I have the feeling that you've converted a few people in the audience to try out Q for sure.
Yeah, we'd certainly be very interested. As I said, Marcel recently left Google to work on Q full time, and Q has sort of been properly forked to be to live outside of Google now as well. So we're looking to grow the project quite considerably. And so if people have use cases they want to challenge us with, please just head over to either the Q Slack or GitHub discussions within the Q project, and fire any questions. We're super happy to be challenged in that way.
Sounds like a call for contributors as well.
Yeah, very much. Very happy. Some of the best contributions we've had are genuinely from people who've just tried to use Q, found rough edges with it, or just sort of found, it doesn't really work for this kind of workflow here. How can it be adapted to that? So that kind of feedback is incredibly valuable. And yeah, as I said, has been one of the main sources of contributions that folks have made so far.
Awesome.
Well, thank you so much.
Thank you very much.
Just for everyone watching, of course, you can also always receive more updates on DevTool Time. And again, a call out for those who are interested in Q. You can check out more information on Twitter. And I'm really looking forward to you in 2 weeks. As always, we will have Adam Gordon Bell here at DevTool Time, September 29th. Come check us out. And yeah, we'll definitely follow up with a recap. So thanks, everyone. See you in 2 weeks or so.
See you, everyone.
Thank you.
Bye.